Hi, my name is Jeremy Hartman, and I'm here to talk to you about something we called PIPEFAIL internally at Cloudflare. It's an interesting distributed systems problem, and I hope you enjoy this talk. I am responsible for production engineering at Cloudflare, which production engineering has a lot of different definitions across the rest of the industry. Here at Cloudflare, that actually means network, SRE or site reliability engineering, observability, change, and health. All of that wrapped up just means the availability of the overall platform. And production engineering itself is here to make sure that customers can access Cloudflare services, the customers behind it, everything that we actually serve out there. That's the availability, that's production engineering, and that's us. We have a jam-packed agenda, so I'm going to try and get through this as best I can, and hopefully it's a fascinating exercise for everybody. So first, I'm going to talk a little bit about Cloudflare and a little bit about the services that we provide, including the cast of characters, things that were involved in this particular incident. We're going to talk about the change, and it's always a change. It's always something that we're changing in the environment, or at least most of the time anyway, that causes these kinds of incidents. The slowdown or the impact to the customers themselves. What were the customers feeling, and why did that happen? The aftermath, that's sort of the post follow up, and after everything was fixed, what did we do? What were we investigating? And then the wrap up of what were the learnings from this kind of event. I do want to first say thank you. I do appreciate your time. I know that your time is very valuable, and I do hope you find this to be an interesting talk. I also want to reference our blog. This is a source of excellent information, including the write up on this particular presentation. A gentleman named Alex Forrester should have a lot of the credit or all the credit for writing this up. A lot more detail in the blog post itself. I very much encourage you to go and take a look. I want to go over really quick, why did I pick this incident? This is a very interesting distributed systems problem. It has all of the hallmarks of something, with a very complex system interacting together. So I figured this would be a nice way to go. And again, just send me an email if you want to give me any feedback. Anything is fine. I'm always interested to hear how we're doing or how I'm doing. Okay, some key concepts. Cloudflare is at its heart a massive scale reverse proxy service, at least the services that I'm talking about today are, which includes an integrated DDoS system as well as firewall rules. It's important to note that we have a ubiquitous service profile, meaning that every service runs on every server around the world. It's kind of important for this particular incident as well. And I want to introduce a little bit of vernacular called frontline service, which really is the service where the first byte comes into our system. So that's the first time that we interact with a byte that's coming in. Okay, let's start to talk about a cast of characters. I have a nice little diagram here with our users sitting over there on the left. You can see that they're performing gets and puts into our system. They're very important, so I will always want to bring up those as a cast of characters. As I mentioned, the first thing that happens is that packet hits our frontline service. That actually then passes some request samples and gets some information from this service called DOSD, which is on the right there. And then lastly, the piece I want to introduce is Quicksilver, which actually is a key value store that we use for configuration management that is also informing DOSD and giving it some information to be able to help that frontline service. So let's talk a little bit more and thicken this plot a little bit. In addition, on the back end, we have something called the addressing API. And its job is to keep information about addresses across the internet. And it actually informs Quicksilver, which then informs DOSD. So you can see that diagram kind of working there. Addressing information itself doesn't really change a whole lot. So this is an async job. It happens once an hour, and it happens at 10 past the hour via a Kubernetes job in our core data centers. And again, Quicksilver, I'm going to reference Quicksilver a couple times throughout this talk. Key value store, we built it to be able to very quickly distribute those key values out to our data centers. That happens in milliseconds, and the services themselves access those key values in microseconds. So it's really, really important for how Cloudflare delivers its service. Okay, the best of intentions. Everything starts with the best of intentions. What happened on that day? So we had a change that was queued up to fix the behavior of FL as far as how it was handling a no transform header. We had noticed that for a while, actually, we had not been responding to the no transform cache control header, and we were going to try and fix that. So we did. We pushed that particular release out, and customers kind of started calling in and said, hey, we noticed you changed something. What happened? And it turned out that customers had actually started relying on how we were reacting, even though it was non-conformant and not RFC compliant. So a rollback was requested. As always, at Cloudflare, we take a staggered approach. So we went to our first we went to our tier 2 and tier 3 data centers, or smaller data centers, and rolled that out there, made sure everything was okay, and then started our second batch into our tier 1, or our larger data centers across the world. This pretty graph right here just shows how it kind of flowed across the entire system. So you can see the two batches very clearly, one at about 1924 and one at about 2010. This is all UTC on December 16th. Something broke. So immediately we actually started to get a few alerts on metrics that trigger what we call a P0, or a highest level all hands on deck sort of alert. We started to see in global CPU roughly a 45% drop. This is an example of what this actually looked like per colo. If you can actually, those little lines in there are, each one of those is a different colo, and you can see them starting to cascade across and going red. In addition, we have another alert that, again, just immediately triggers a P0 called a global traffic alert. We saw about a 20% drop in total traffic across the entire fleet globally. So this was not a detection problem. We detected it very much immediately. So then we move right into, what are we going to correlate? How are we going to get to our first clue? So, okay, taking a look across the system, we noticed pretty quickly, actually, that DOSD itself, which is the daemon that runs on the systems that handles those mitigations and informs FL, those mitigations dropped to 0 across the fleet. In addition, DOSD had started to panic. It had started to crash loop itself. So pretty clear signal that something was going on with DOSD that we didn't know, that shouldn't have happened, right? Okay, next step, correlation and remediation. So logs, DOSD started to tell us, okay, there's a value it was looking for inside of Quicksilver itself, and DOSD didn't know what to do about that and said, oh, I'm gonna panic, I'm gonna crash. The team said, okay, we can go off and fix that. What populates that particular value? Oh, it's this cron job that runs every, at 10 after every hour. Let's just go run that and see if that fixes the problem. Again, we're in full remediation mode. Let's get the service back online. That's the most important thing entirely. What do we go off and do? So as soon as they did that, the alerts cleared just about immediately. Again, Quicksilver itself is very, very, very fast. And the CPU levels and traffic levels started to come back to normal. Looked great. However, so we got a thumbs up there. That's great. Problem is we still didn't know why this field was empty. Again, this is a field that's been populated for a long time. No problems have been encountered in the past. Didn't know what was going on there. And we also didn't know why it impacted the edge so terribly, right? Why did FL stop forwarding traffic? Why did we actually drop all that traffic and drop all that CPU? Let's go find out. So how did that empty value get there? So we went off and looked at the cron job itself. Runs every 10 minutes. What does that cron job do? Pretty simple. Queries the addressing API, puts them in a TOML file, and then populates Quicksilver from that TOML file. Okay. Well, why is this a problem? Can you spot the bug itself, right? What's going on here? The problem is that if there's an empty value, or if it times out, the DOS CTL is just going to write that empty value into Quicksilver. There's no actual error handling in this particular bash script, right? So in this case, we're like, well, that's not very good. Let's make sure that, in fact, we get a valid value before we go off and write to Quicksilver. Okay, we can fix that, no problem. Next question would be, hey, why did Quicksilver take this value? Aren't we doing any sanity checking? Aren't we doing any field level validation? Well, it turns out that an empty value itself is actually a perfectly valid TOML document. Like that's fine. Empty is a perfectly valid thing. So we just accepted it and tried to move along in Quicksilver. Okay, that makes some sense. Next, as I mentioned before, we have to figure out why FL itself, or why Frontline, slowed down. This is an interesting diagram that shows how Frontline itself relies on DOSD and what it uses DOSD for. So again, those are the users on the left side that are requesting services from Cloudflare, and that request comes in, hits Frontline. Frontline is asking DOSD for information. but it's not doing it all the time. It's doing it in a polling manner and then populating an internal cache. We don't need to ask Dosty all the time. We don't want a busy loop on a Dosty or anything like that, right? So in this way, this is how Dosty and Frontline interact. We said, okay, it's not in the direct traffic flow, polls every few seconds. What's going on here? But then you remember, oh yeah, we actually bounced FL with the rollback itself. When we did that, the caching layer was empty, right? So now we have an empty cache, and anytime a packet's coming in, it's getting a cache miss and going out to Dosty and saying, hey, I need some information. In that loop, in that particular code, was a 5-second timeout on that cache request when the cache was empty itself. So we had head of line blocking for 5 seconds for packets coming in to Frontline across the entire network. This was our slowdown. In case we're counting, which I am, now we have two simultaneous issues that have to happen at the same time. The concurrency has to be 2 so far that we've talked about for this actually to break us, right? So let's move on. We're still investigating this. It's like, wait a minute. We did this twice, right? We rolled back and everything was fine. It took about, a half an hour or so, a little bit less, to roll back starting at 1925 UTC. That was okay. And, we thought we were being safe about it, but then it only occurred after the second one. Well, wait a minute. Oh, what happened? So that second one started at 2010. That cron job, as I mentioned earlier in the talk, that cron job fires every hour at 10 after the hour. So it just so happens that we fired that second rollback at 10 after the hour. And that's also when that cron job fires off. So when that rollback happens, it starts to talk to the addressing API. The addressing API got very, very, very busy at that time. It slows down. It doesn't drop requests, but it does slow down on requests. And it slowed down just enough that the cron job itself times out. So as we mentioned, there was no error handling on the cron job. It returns an empty value to Quicksilver. Quicksilver populates that empty value, and off we go. So, okay, that's a lot. I know I went over a lot. Let me break this down really quick. What happened? We had a manual rollback. It triggered a thundering herd problem for our addressing API. That overloaded the API. We had an error in a Kubernetes job that resulted in invalid data being populated into Quicksilver, at least invalid as far as DOS-D was concerned. We had DOS-D that didn't know how to handle that invalid data and really didn't fail properly, right? Crash looping is not exactly how we want to see services respond to an error in configuration or any other problem, to be honest with you. There is a way to gracefully degrade here, and that did not happen. In addition, we had a dependency from Frontline on DOS-D that, because of this dependency, was kind of unexpected. In other words, Frontline, we did not design FL or Frontline to be dependent in this way on DOS-D, but because it was head of line blocking all of the packets that were coming in, even though, again, there's probably a better way to handle this, right? Something else could happen from a systems interaction so that we just don't head of line block there. And all of this had to happen when it was all kicked off at 10 after the hour. Literally, the timing of this was a critical component for the failure. If it had kicked off a little before, a little bit after, we wouldn't have been in the same situation, but we also wouldn't have seen this sort of insidious thing hanging around and don't know if we would have been able to fix it or find it. So, I kind of mentioned on this slide that no sunspots were involved in this incident, but, it's kind of one of those fun things that sunspots usually rear their ugly head, but not in this particular case. So all of these things absolutely had to come together at the right time, with the right set of circumstances, the conditions, all the things that go along in order for this to happen. It's exactly the kind of distributed systems problem that you get when you have all of these complex systems interacting. You have massively distributed global scale. You're trying your best, but this is exactly what this is the kind of scenario that you end up finding. So at the end of the day, what did we learn? Really, there's two streams here, and I want to call out the technology piece first. Certainly, hardening the addressing API is critical. Obviously, that should not fall over, or at least not slow down in the way that it did when it was queried by all of the servers out in the data centers. Bash script hardening That was incorrect. Obviously, we should have some better error handling with bash scripts. Frontline should not have reacted the way it did. Frontline itself, should be able to handle a restart more gracefully, should be able to handle a lack of information from DOSD a little bit better. It's certainly not head of line block every 5 seconds. That is not the way to go. And then DOSD, as I mentioned, it had an invalid field. Didn't mean that it lost all the rest of its information. So, when when itself started to fail, could have regressed much more gracefully at that point in time also. But let's not forget the process side of this equation. This started with fixing the FL behavior for compressed content or compressed cache header. Okay, could have been a little bit, or could have been a lot more thoughtful about that particular fix. Didn't quite anticipate the customer impact, or that customers were relying on our buggy behavior or our non-compliant behavior. There are additional checks we could have taken to make sure that didn't happen, that wouldn't have put us in this situation to begin with. The last and not least is the accelerated manual rollback. Rollback is is a superpower. It's important to be able to be very, very good at it. And rolling back quickly is also important. Like, you got to be able to do that. But most important is the safety of that rollback and validating that the rollback procedure is safe. We know it's tested really, really often, and that any systems that are in the dependency chain for a rollback can handle sort of that button, right? The big red button. So lots and lots of learnings. You can go off, like on the blog post that I mentioned at the beginning. There's more information, and also some of a little bit more information about what our follow-up items were. But this incident was challenging for our customers. It was challenging for us, but it provided a lot of very interesting lessons for us going forward. Thank you for your time. I do appreciate it. Again, I know your time is valuable, and I hope you enjoy the rest of the conference.